This is the video introduction to Lesson 30, Resistor, Wattage, and Watt's Law in the Mr. Circuit Basic Electronics Lab number 2. It is also the last lesson in this lab. Whenever there is electric current flowing, there is heat being generated. This heat is measured in watts and is defined by volts times amps. This is known as Watt's Law. Heat is dissipated through mass. The more mass the component has, the more heat it will dissipate. In other words, the bigger or the heavier that the component is, the more heat it will dissipate. If there is more heat being generated than the component can dissipate, the component gets hotter and hotter and goes into what we call thermal runaway. With thermal runaway, the component finally becomes too hot and self-destructs by burning up or possibly opening the circuit. Manufacturers of electronic components give a wattage rating to their products, or they specify how much voltage to apply and how much current will flow. All this information is important for designing and repairing electronic devices. Let's talk about resistors. Some of the ratings for resistors are ohms, tolerance, and watts. Common wattages are 2 watts, 5 watts, 1 watt, half watt, quarter watt, eighth watt, and so on. How do we determine the wattage that we need for a resistor? Let's take a circuit with a 9-volt battery and a 390 ohm resistor. How many watts should this resistor be able to handle? Watts are defined by the voltage drop across the component and the amount of current flowing through the component. In our circuit, we have 9 volts across the resistor. Using Ohm's law of I equals E divided by R, I equals 9 divided by 390, or I equals 0.023 amps. Then, using Watt's law, we multiply the volts times the amps to get the amount of heat needed to be dissipated by the resistor. So, we have 9 times 0.023, which equals 0.207. What does that tell us? It says that the resistor has to dissipate 0.207 watts. So, a resistor of a quarter watt or 0.250 watts would work just fine because it can dissipate 0.250 watts, which is more than the necessary 0.207 watts that we calculated with Watt's law. Let's talk about an LED and the watts of heat it can dissipate. Remember the red LED? The manufacturer says it needs 2 volts across it and requires 18 milliamps of current. So how many watts of heat can an LED dissipate? We just have to multiply the volts times the amps to find out. We multiply 2 volts times 0.018 amps, and we get 0.036 watts. What happens if we were to increase the voltage across the LED from 2 volts to 9 volts? If we put a 9-volt battery across the LED with no extra resistor to reduce the current, what happens? Well, the 9 volts will try to push more current through the LED, causing the LED to heat up and go into thermal runaway, and the LED will self-destruct. Another way to look at this is, since the LED is designed to conduct a current of 0.018 amps with 2 volts across it, we can calculate its equivalent resistance. If we use Ohm's law, where R equals E divided by I, that would give us 2 divided by 0.018, which equals 111. 111 what? 111 ohms. So a red LED is equivalent to a 111 ohm resistor. So, if we were to put 2 volts across a 111 ohm resistor, we would have 0.018 amps of current flowing. How many amps of current would flow if we were to put a 9-volt battery across a 111 ohm resistor? Using Ohm's law, we get I equals E divided by R, or I equals 9 divided by 111, or I equals 0.081 amps. But 0.081 is too many amps for a red LED. We only need 0.018 amps. Also, applying Watt's law, we would get 9 volts times 0.081 amps, and that would equal 0.729 watts. And 0.729 watts is way above the 0.036 watts that an LED is rated at. So if we connect the 9-volt battery directly to this red LED that is supposed to run on 2 volts, the LED will overheat and self-destruct because it would be trying to dissipate too much heat. Now, with what I have shown you in this introduction, you should be able to use Ohm's law and Watt's law to determine the wattage needed for a resistor in a circuit. Let's try another example. Suppose you have a circuit with a 470 ohm resistor and a 9-volt battery. How many watts does the resistor need to be? To start with, how many volts are dropped across the resistor? The full 9 volts of the battery. How much current will flow? Use Ohm's law to calculate the current. I equals E divided by R. I equals 9 divided by 470. I equals 0.019 amps. Then, using Watt's law, we get W equals volts times amps. W equals 9 times 0.019. Therefore, W equals 0.171 watts. So how many watts does the resistor have to be rated at? Answer, anything above 0.171 watts. Can we use a resistor rated at 1/8 of a watt, which is 1 divided by 8, or 0.125 watts? No, it's too low. 0.125 is less than 0.171. Can we use a resistor rated at 1/4 of a watt, which is 1 divided by 4, or 0.250 watts? Yes, because 0.250 is higher than the required 0.171 watts. What I have explained so far should give you a little better understanding about watts. A watt is a measurement of heat. The power company sells electricity in watts, specifically in 1,000 watts per hour, or kilowatts per hour. If you're charged 20 cents per kilowatt hour, it means you have to pay 20 cents to run a 1,000-watt hair dryer for an hour, or a 100-watt light bulb for 10 hours. The power company provides about 120 volts. The amount of current you draw times the 120 volts gives you how many watts you're using. If your home is drawing 50 amps of current at 120 volts, it's drawing 6,000 watts. If you draw 6,000 watts for an hour, that is 6,000 watt hours, or 6 kilowatt hours. How much would it cost at 20 cents per kilowatt hour? It would cost $1.20 an hour. If you did that for 8 hours a day for 30 days, that would be $9.60 times 30, or about $288 a month. That finishes the video introduction for this lesson on wattage and Watt's law. When you fill out the answers on page 30B of your lab manual, and you have completed all of the other 29 lessons of this lab, you qualify for the Certificate of Training for the Mr. Circuit Basic Electronics Lab Number 2. In order to receive your signed certificate, contact your instructor or proctor. Please note that on the back of the certificate will be listed all the skill set that you've covered in this lab. I hope you're enjoying learning electronics and will continue to learn more. Thank you from everyone here at Mr. Circuit Technology.